So for today's video, we have to integrate sin x to the power 5 times cos x to the power 5 dx, and we're forced to use the substitution u equals cos squared x. Let's try it out. So the first thing we should do here is to differentiate u, so we can say that du by dx is equal to 2 cos x to the power 1, so we treat this like a power function, multiplied by negative sine x. And we can simplify this a little bit further for all intents and purposes and say that this du by dx value here is going to be equal to negative 2 cosine x sine x. And to simplify this a little step further, we can say that du divided by minus 2 sine x cosine x, that is going to be equal to dx. And we're going to need to replace that inside of our formula here. So we can go ahead and do that now. So our integral becomes the integral of, and it's important not to skip any steps here, so don't rush, sine x to the power 5 times cosine x to the power 5. You can replace the dx to start with du divided by negative 2 sine x cosine x. And so you'll notice here that the sine x's cancel out quite nicely, so we can go to our next step. I would like to take this negative 2 at the bottom outside of the integral to make our life a little bit easier. So I'm going to go ahead and first say it's minus a half of the integral. So I notice here that I have sine x to the power 5 and cosine x to the power 5. And then I have a sine at the bottom and a cosine at the bottom. So these are going to simplify quite nicely. So I can say that this is sine x to the power 4, and I have cosine x to the power 4 as well. And this is du. So noticing that cosine to the power 4 of x is actually u squared, since we substituted u as cos squared, we can say that this is minus a half of the integral of sine to the power 4 of x times u squared, and then we still have du. Now, something that's really useful is that whenever you have sine squared or cos squared, you can always swap them around for each other. We have a very nice swap formula which we use in trigonometry, where you can say that sine squared x plus cos squared x is equal to 1, and therefore when you have sine squared x, you can always say that it's 1 minus cos squared x. And we're going to use that here to change sine squared squared into 1 minus cos squared. So let's try that then. We'll have minus a half of the integral of sine squared x squared, which is going to be equal to sine to the 4, times u squared, and then times du. Now for our next step, we're going to change the sine squared into the 1 minus cos squared. So we can say minus a half of the integral of 1 minus cosine squared x squared times u squared times du. Okay, so 1 minus cos squared, I can change that into 1 minus u, since u is equal to cos squared. So we can say this is minus a half of the integral of 1 minus u squared times u squared times du. And so here we have 1 minus u squared in our bracket, so we can remember that a minus b, if that was in a bracket squared, that's equal to a squared minus 2ab's plus b squared. So this is a expansion identity. So we can say this is minus a half, we can use that in our integral, of the integral of 1 squared, so 1 minus 2 times u plus u squared, and all of that gets multiplied by u squared times du. So this will be minus a half of the integral of u squared minus 2u cubed plus u to the power 4 du. Now, using our rules of integration, we can integrate each one of these terms. We just up the degree by 1 and divide by the same number. So we'll have minus a half. And so for our integral here, we can say that this is going to be u cubed divided by 3 minus 2 times u to the power 4 divided by 4 plus u to the power 5 divided by 5, and let's not forget plus a constant. So expanding the brackets here, we can say that minus a half times u cubed over 3 will do minus 1 times u cubed is negative u cubed at the top, and at the bottom 2 times 3 will be 6. For our second term, the 2 quarters can simplify into a half. A negative times a negative is a positive, so I can say plus, and then a half times a half is going to be a quarter, so it'll be u to the power 4 over 4. And for the last term, a negative times a positive is a negative. 2 times 5 is, at the bottom is 10. So we'll have u to the power 5 over 10 and then plus a constant. Now let's not forget that u was equal to cos squared x. So we can actually change this and we can say that we have minus, so cos squared cubed is going to be cos to the power 6. So cos to the power 6 of x over 6. And then we're going to have plus cos squared to the power 4, so plus cos to the power 8 of x over 4. And then we have minus cos squared to the power 5, so this will be minus cosine to the power 10 of x over 10, and then plus a constant. And I think this is a wonderful place to stop for this question. Really interesting question. We were able to use substitutions, we're able to use identities, trig identities, and just very good mathematics overall to get to a very solid answer using the restriction from the question, which is to say that u is equal to cos squared x. Thanks a lot for watching the Mathemagic channel. If you're doing calculus and you're doing integrals, I hope this was useful to you. Make sure to like and subscribe so you can watch more of our materials. Thank you for being here today. We appreciate your support. Bye-bye.